Hey guys, so welcome back to your next class. In the previous session, we were looking at certain things like what is potential energy, how do I calculate it, and also we looked at what is kinetic energy and how do I measure kinetic energy also. Right? Let's take a slightly closer look at both of these energies. Okay, if you think about it, when we talked about these energies, they kind of coexisted with each other, correct? So we speak of one object which has potential energy, and then suddenly that changes into kinetic energy, right? For example, a ball sitting in your hand, right? It has potential energy because it's not moving and you just have it at a certain height, and the moment you throw it up, it gets kinetic energy, right? Because it's moving really fast. So that is one example. So how potential energy kind of just became kinetic energy, and how the same object, like for example, if you have something placed at height, you drop it, then that potential energy again becomes kinetic energy and starts to move down. Okay, so these potential and kinetic energies are kind of interrelated. Okay, so whenever we speak of potential energy and kinetic energy, we will be using like one term that we have. Okay, we call this as mechanical energy. Okay, so what is mechanical energy? So every object will have something called mechanical energy, which is nothing but it is the sum of your potential energy plus your kinetic energy. Okay, if you add them both, you get something called mechanical energy. So what this tells me is it is possible for an object to have both potential and kinetic energy at the same time. It's not necessary that if my kinetic energy is there, that means I have zero potential energy, or if I have some potential energy, that my kinetic energy has to be zero. It's not necessarily like that. Okay, let's try to elaborate that with an example. Let's take a very simple example of a pendulum. I mean, you must have heard the word pendulum, right? Pendulum is nothing but like you have a string attached to like a slightly heavy object, like what we call as a pendulum bob. Okay. Now, what do you do with pendulums is generally you kind of fix them to a place and say that this is the resting position of my pendulum, right? It's my resting position. I will call it A. Okay. When I don't do anything to the pendulum, it's untouched. It is there. Now at A, it has a certain amount of energy with it, right? How much it is, I don't know, but it'll have a certain amount of energy because it's hanging at a height. Okay, at some height. But what happens when I leave this bob? If I just let go of this, then you will see it will swing back over here. Okay. The reason it swings back is because since the potential energy is increased, it will try to like get rid of it somehow, or just put it somewhere else. Okay. Since it moves like this, it means that it has some kinetic energy now. Okay. So now I can say that the kinetic energy of this object has increased when it's coming from B to A. Okay, just I've written it with the arrow. Now, when it comes down back to A, all this while, if you see, the height is decreasing. Okay, so from here to here, the height is reducing. So I can say that the potential energy is reducing, but the kinetic energy is increasing. Okay, so I'll say potential energy will be reducing. I'm just putting a down arrow for that. And kinetic energy is increasing, up arrow. Once it comes here, you know that the pendulum will not stop, right? It's going to keep moving in the opposite direction and reach pretty much the same height on the other side. Okay, or a little less sometimes, depends. Okay, I'll call this position as C. Okay, now this C is again at a certain height over here. Okay, which means that as I'm going from here to here, my potential energy is again increasing. Okay, because my height is increasing. But at the same time, after we come here and we start reaching there, you'll see that the pendulum starting to slow down. Okay, it will start to slow down. So I can say that my kinetic energy is decreasing. Only because it decreases will the pendulum be able to stop in the final place, right? Now, again, once it stops there, since again potential energy increased, it is going to try to come back down to get rid of that potential energy. Again, while moving down, I will say that my kinetic energy has increased, is going to keep increasing, and my potential energy will keep decreasing again because the height will reduce back to your original position. Okay, so this is one movement that keeps happening for a while. After some time it will stop because some energy is lost to the surroundings and stuff like that. So resistance is what we call it, air resistance, right? So this is basically what I want you to notice over here is there's never a time when a new sort of energy is coming in. Okay, it's the same energy being used in different forms. The potential energy that is increased over here, it changes to kinetic energy. Only when it is changing to kinetic energy can my potential energy reduce. Okay, and the same goes with kinetic energy. Once the kinetic energy is reducing, it's changing into potential energy. Okay, there is no new energy coming from anywhere. It's the same energy being changed in different ways. So this is what we call as law of conservation of energy. Okay, so what this law states is that energy cannot be created or destroyed. Okay, so I can say energy can neither be created nor destroyed. It can only change from one form to another. Okay, meaning if I am starting with kinetic potential energy, it will change into potential changes to kinetic, kinetic changes to potential. That is one example. Okay, can be changed from one form to another. This is a very simple example. Now this law of conservation of energy applies to all forms of energy that exist. Okay, so meaning even if I talk about something like electrical energy, for example, it will still apply there. Okay, think about it, in nature there are actually a lot of forms of energy. There is light energy, right? We know that sunlight is coming down from the sun all the way till here. Now that energy, we know there's something called solar panels, right? We can use solar panels to convert that sunlight or that light energy into electricity. So in that form we are trying to convert light energy to electric energy, right? Same way, you can also talk about something like batteries, right? A battery is nothing but we can use chemical energy, because inside battery there will be some chemicals, and they change to again electric energy, right? And if you also talk about, if I'm using that, what am I using that electricity for example, if I want to use that for a bulb, it means I'm changing from electric energy, chemical energy to electric, and from the electric energy I'm getting back light. Okay, so all of these things are just changing the same energy that is already there. Okay, this is what the law of conservation of energy says. It is impossible for anyone to create new energy. Okay, the energy that you use or get is already existing in some other form. You're just changing its form. Okay, you can think of more examples like this wherein energy is being created, or changing from one form to another. Feel free to just drop a comment down below and just tell us an example of where you think what energy is being converted into what energy. Okay, so this is what we are going to cover for today, the law of conservation of energy. Couple examples of where it is changing. You should be just able to guess, like if I'm asking you like what energy is changing into what energy in this case, for example. Okay, it's quite a simple thing to think about. Okay, so that's it for today. If you have any doubts, comments, anything to say, you can just drop them in the comment section below. And I'll see you again in the next class. Thank you.